Hello, welcome to this video. Today we're going to be exploring two customer stories about using TiDB Serverless to solve small and medium-sized projects without the effort of self-hosted TiDB deployment. Since the introduction of serverless databases, they have attracted significant attention from many users. Some customers who have already used serverless databases in their projects have provided feedback, stating that due to its automatic scalability, high availability, security, and most importantly, the pay-as-you-go pricing based on data operations, they have found serverless databases to be the best choice for their small to medium-sized projects. Let's explore two customer stories for TiDB Serverless. Let's start with customer story number 1. The first customer we would like to introduce was developing a vehicle recognition system that operates as follows. Step 1. Vehicles pass through a specified location, at which point an image sensor captures images of the vehicle and license plates. Step 2. The system sends the captured image to a visual intelligence platform, which is an SDK service on the cloud that provides image feature extraction. This platform changes based on the number of image processing operations. Step 3. The recognized features are stored in a database and undergo data processing. During the design of this project, it was discovered that the number of vehicles passing through the sensor varied greatly with daily traffic peaks. For example, there were significant increases in vehicle traffic during 2-hour periods starting at 9 a.m. and 5 p.m., compared to the period between 2 a.m. and 5 a.m. where vehicle traffic was almost 100 times lower. As a result, the system's load would experience significant fluctuations. The customer did not want to invest human and material resources in maintaining, ensuring high availability, and scaling the database, so they chose a cloud solution. However, here's the challenge. Compared to the pay-per-operation charging model of the Visual API platform, the cloud database charged based on the configuration with a fixed hourly rate once the configuration was selected. To counteract this cost, the customer chose TiDB Serverless. With TiDB Serverless, not only can the database automatically scale and support zero downtime, but it also charges based on the amount of data processing. On the customer's bill, payment for the database usage only occurs during the peak hours of the day, while at certain other times it falls within the free load range. As a result, the customer confirmed that TiDB Serverless not only meets their project requirements in terms of performance and high availability, but it also represents their best options in terms of cost. That was very insightful. But it makes sense to visit another customer story to assess TiDB Serverless against a second use case. Our second customer is maintaining a data query and analysis system. Due to frequent adjustments in the structure and business processes of certain tables in the system, as well as the frequent addition of statistical reports, there can be 3 to 6 versions of updates and releases every day. Here's the approach and the problems they encountered. Step 1. Developers update the code and compile and test in the testing environment, which passes successfully. Step 2. The code is now deployed to the production environment. Step 3. The new version goes live. The problems often occur in Step 3. Due to the large size of the production environment's database, which is 5 terabytes, while the development environment's database is much smaller at 500 gigabytes due to cost considerations, engineers cannot guarantee consistent performance of their code across different environments. Therefore, it often happens that after deploying the updated code to the production environment, the efficiency of the entire query and analysis system decreases or even becomes sluggish. Each deployment of the program has the potential to fail, causing significant impact on project progress. In response, the customer attempted to deploy the databases of the development and production environments both on TiDB Serverless. TiDB Serverless charges based on data operation volume rather than data storage size, resolving cost concerns for the development team when using 5 terabytes of data in the development environment. In this way, TiDB development and production environments guarantee consistency on the database level at the very least. From the perspective of development efficiency, since the development and production environments are consistent, when engineers update the code and compile and pass the tests, and then deploy to production again, the chances of deployment failure due to inconsistencies between the two environments is greatly reduced. Before explaining why TiDB Serverless can achieve automatic scalability and pay-as-you-go based on data operations, let's first understand the architecture of TiDB Serverless. TiDB Serverless is built on the evolution of an architecture that separates the compute nodes and storage nodes of the TiDB database. Let's first take a look at the compute nodes. The compute nodes are composed of two parts. One part is the isolated compute nodes, where each database tenant can only use the allocated compute nodes, also known as the SQL layer. The other part is pooled compute nodes, where the compute nodes are in a resource pool and TiDB Serverless allocates compute nodes from the resource pool to tenants with high load. The term compute nodes here refers to the TiDB server that processes SQL or the MPP worker nodes that assist in AP operations. On top of the compute nodes is a shared layer called the gateway. Users are routed to the database tenants they need to access through the gateway, and the compute nodes of each tenant are isolated from each other. Next is the storage layer, which is shared and divided into two parts. The first part is block storage, which includes various storage engines such as row storage engines like TiKV and column storage engines like TiFlash. They are responsible for high-speed reading and writing of structured data. The other part is object storage, such as S3, represented by the region shared storage in the image. It provides unlimited storage, high availability, and low cost with high security. Now, let's explain how the compute layer achieves automatic scalability and pay-as-you-go based on data operations. When the load of a tenant is low, we can allocate a small number of compute nodes, aka TiDB servers, to the compute layer as shown in the image. In this way, we can only charge based on the computing power and I/O read-write volume generated by the small number of compute nodes. When the load suddenly increases, TiDB Serverless can allocate more compute nodes from the compute node resource pool to meet the current load. Of course, users need to pay based on the computing power and I/O read-write volume generated by the automatically scaled compute nodes. Finally, when the high load period for a tenant ends, TiDB Serverless returns the recently allocated compute nodes to the compute node resource pool for other tenants to use. This allows customers to pay based on the computing power and I/O read-write volume generated by the smaller number of compute nodes once again. Therefore, TiDB Serverless relies on the automatic scheduling of multi-tenant isolation and pooled compute nodes to achieve automatic scalability and pay-as-you-go based on data operations. Next, let's focus on the shared storage layer, which is also called the cloud storage engine. It consists of two parts, the shared storage layer and the shared storage pool. The shared storage layer is a shared storage engine layer that includes block storage engines such as TiKV and TiFlash. These storage engines have advantages such as high-speed performance, suitability for frequent modifications, support for structured data read-write, and fine-grained control. However, their disadvantages are expensive prices and limited data storage capacity. The shared storage pool is a shared object storage like S3. Its advantages include unlimited capacity, fast speed, extremely low cost, high availability, and security. Its disadvantages are the inability to precisely control read-write granularity and the lack of support for structured data read-writes. It can only read data based on object names, aka keys, and values. TiDB Serverless combines the advantages of both. For example, in User Story 2, we first take advantage of the unlimited and low-cost shared storage pool object storage to store data for development and production environments while ensuring that the data volume is consistent between the two environments. Then we use the isolation of the calculation layer to treat the development and production environments as separate tenants. Users access the isolated TiDB server through the gateway, and then the TiDB server reads the storage engine, which is the block storage, from the shared storage layer. The shared storage layer retrieves the required data from the shared storage pool object storage and performs read-write operations on relational data. The direct result is that users can store large amounts of data in TiDB Serverless without worrying about the cost caused by data volume. At the same time, TiDB Serverless achieves scalability that traditional databases cannot achieve in this manner. With these two customer stories, we've been able to confirm the value of TiDB Serverless and how it helped solve small and medium-sized projects for two of our valued customers. If you would like to know more, please visit TiDBcloud.com and set up your very own serverless environment so you can get to work immediately. Thank you for watching, and we look forward to seeing you next time.